Operational amplifier in general, it has a high gain and signal conditioning. The general operational amplifier, it has high gain, and this DC amplifier, the gain is typically around or above 100,000. It comes as an IC chip or integrated circuit. It has two inputs, where one is inverting and the other is non-inverting, denoted plus and minus. The output depends on the connection made to the inputs, and the other inputs there are two. There is a negative and a positive supply inputs, and then there are two offset null inputs which enable connection for non-ideal behavior. The voltage gain is the ratio between the outputs and the input voltage measured with respect to Earth. The input impedance is the input voltage divided by the input current, denoted Zin. The output impedance is the output voltage divided by the output current, denoted Zout. Here below to the left you have the general amplifier diagram or block model, where you have the input voltage going into the amplifier and the output voltage going out of the amplifier, and you also have the input current and the output current. On the right you have an example of a operational amplifier chip called 741 operational amplifier, where you have the two inputs, the inverting and the non-inverting ones, on inputs 2 and 3, and then you have the negative and positive power voltage supply inputs on pin 4 and 7, and then on pin 1 and 5 you have the offset null inputs. Now, the operational amplifier has some parameters to it, which are the open loop gain, where you want it to be infinite, and you have the input impedance, which you also want to have infinite. You have the output impedance, where you want it to be almost zero or zero. You have the input bias current, which also you want to have zero. You have the common mode rejection ratio, which you want to have infinite. But that's for the ideal model, and the most calculations are approximated or done with the ideal conditions. But sometimes you also have to know what you should expect, or some typical numbers, where you can say that the open loop gain should be above or around 100,000, and the input impedance should be high. 2 megaohms could be typical, and the output impedance should be very low, or 70 ohms might be typical. The input bias current could be around 40 nanoamperes, and the common mode rejection ratio could be somewhere around 100 decibels. As an example, there is that chip that I mentioned just before, that the 741 operational amplifier, and I have only filled in for two parameters here, for the input impedance and the output impedance, where it is 2 megaohms for the input impedance and 75 ohms for the output impedance. The other parameters you should try and find the data sheet for as an exercise. Now, we have a schematic symbol and an equivalent circuit for the operational amplifier. To the left you have the schematic symbol, where you have this triangle with the minus and the plus input. The minus is the inverting input and the plus is the non-inverting input, and then you have the output for the output voltage. The equation to calculate the output voltage is that you have the open loop gain times the difference of the input voltage on the non-inverting input minus the input voltage from the non-inverting input. So this is the schematic symbol and the equation to calculate the output voltage. But we also have a equivalent model, which is used to describe the behavior of the circuit and to help understand this about that you want to have infinite values for the input and output impedance, for example. Now, this model is that you have the inverting input V minus, and you have the non-inverting input V plus on the left side, and between them you have the input impedance, and you, as said before, want it to be infinite so that there is no current flowing between those two inputs, and thus the potential of both these inputs would be the same. There should be no potential difference between them. And then you have on the right side, you have the output voltage, where you have the set out, or the output impedance, and you want it to be as low as possible, so it doesn't have effect on the circuit that it comes afterwards. And then you have a supply where you have the, which acts like the amplified signal, where you have the open loop gain times the difference of the non-inverting and the inverting input. And here below you can see equations that tell that the current from the non-inverting and the inverting input should be equal and should be 0 for the ideal model, because the input impedance is infinite. And then you have the inverting potential voltage, and the non-inverting potential voltage should be equal, and that should be because of that the open loop gain is infinite. And you could say that if you subtract these input voltages from the non-inverting minus the inverting one, you should have 0 voltage drop between them, which also supports that the input impedance is infinite. So this are some general information about the operational amplifier.